Hello, everyone. Welcome to another webinar presented by ATG. I'll be your host today, Don Rasmusson, and it feels really good to see lots of people signed into the webinar and attending today. A lot of familiar names there. So thank you, everybody, for choosing to spend some time with us here over your lunch hour to learn a little bit more about Revit MEP and duct routing preferences. And this, in essence, confessions of someone who's done duct design in Revit for many, many years. Want to dive right into the webinar and kind of get started here. As always, everyone, feel free to type questions into the chat window, and I will do my best to get to those questions. If they fall in line with what we're talking about at the moment, we will definitely answer them in the moment. If not, we'll save them for the end and circle back and answer as many as we can. So I'm going to hop right in here and just get started. What you see in front of you, everyone, is good old Revit 2020. I just simply created a new project based upon the system's default template. I'm a big proponent, if you don't have a template, to go to the system's default template and start there for either manipulating and creating your own template, or if you haven't quite done the template thing yet, definitely be using the system's default template, because there's different struggles with the specific MEP to templates inside of Revit, but that is a subject for another webinar, not a subject for today. So when we talk about duct routing preferences, we need to talk about really what we're talking about is efficiencies inside of our Revit environment, and being able to just simply, come to our systems tab and grab our duct command and start routing some duct, or place pieces of equipment and just start routing duct and have things automatically work out for us. So the way that I like to access the duct routing preferences, and just like everything else in Revit, there's 3 or 4 ways to do this. But the way that I like to access it is I'll come to my project browser, I will scroll down my project browser to families, and you see here I've expanded 2 different areas, duct systems and ducts. The routing preferences live under ducts, of course. The duct systems have to do with what the duct is carrying, and the ducts themselves have to do with the actual material and the routing preferences and things like that. You'll notice out of the box, it's divided up into oval, rectangular, and round. You can divide this up however you would like. A lot of my clients don't use oval ductwork, so they don't have oval ductwork in here as an option. They just have rectangular and round. And then, of course, you have tap and T style connections. Taps being the primary one that's used today. T's is not used outside of specialty systems very often. But the first thing I'm going to do here, everyone, is I'm going to jump right into the mitered elbow taps rectangular duct, because this is the #1 duct type that I get questions about here at ATG. And so what I'm going to do here is just simply select mitered elbow taps, right click on that, and go down to type properties. And that will open up the type properties window here. Now you may notice here in the type properties window that there's just a routing preferences edit button. And if we click that, that does open up our routing preferences. But a lot of people forget here our roughness values. Okay. Now your roughness values will impact your static pressure calcs. Roughness values for sheet metal are pretty much universal in a lot of ways, not even depending upon the gauge of the sheet metal. It's the finish that's on the sheet metal that the roughness value really reflects. However, if you have line ductwork or perforated ductwork, right, that does impact static pressure. And you may want to look at that depending upon what you're doing from a static pressure standpoint. So like I was saying about the roughness values, everyone, that's something that we want to take into account for the proper systems or the different duct types that we would be making. But what we're here to talk about today is the routing preferences. So I will go ahead and just hit this edit button. And we're going to open up the routing preferences settings. Now, first thing you'll notice with duct size is not in here. If you remember pipe routing preferences, things like that, that's all size delineated. One of the biggest differences between duct fittings and pipe fittings inside of Revit is that duct fittings utilize equations to size themselves, and pipe fittings utilize lookup tables to size themselves. So they're inherently different between the two, okay? So the first thing that I want to do is just at the very top here, we'll talk a little bit about duct size and what this button can do for you. This is the same thing you find under mechanical settings under your manage tab. you would get to your duct settings. You notice we have rectangular sizes here, you have oval sizes here, and you have round.
Yeah, click that. Just switch it to.
Okay. So if I have, say, for example, under rectangular, a bunch of weird sizes here that you see. Okay. Now these weird sizes are sizes that we wouldn't commonly use, right? They're sizes that are odd sizes or half sizes, which are very rare. One of the first things that I do inside of my Revit environments when I'm trying to tune them for duct is to come in here and eliminate things like a 3-inch duct, because chances are that I'm not going to be using that. Now, that does not mean that the 3-inch duct is completely removed from the project. But what that does mean is that this 3-inch is not going to show up in a size list, and it's not going to be utilized when you type it in. However, if I do find a situation where I do need to use this 3-inch, I can always come back into my settings and turn it back on. That way I can at least type it in. So this is the pull down list. This is taking it off the pull down list inside of your Revit environment. And this is not giving you the ability to even type that size in and use it at all. So I may come in here and say, yeah, we're taking off 3, we're taking off 3.5, I'll keep 4, I'll take off 4.5, I'll take off 5, right? Take off 5.5, I'll keep 6, take off 7, take off 9, right? You guys get the idea here. So this is just me sitting down and tuning what it is that I'm going to do. This pays off actually really big, especially in the scenarios where you have new users or someone who's just coming out of school and doesn't quite understand the fact that we tend to round up our duct sizes to even numbers rather than odd numbers. So you can go through and you can set that. You can do the same thing for oval, the same thing for round. They're all independent controls. But after we've gone and looked at our duct sizing here, I just want to go ahead and take a peek down the list here, if you will, for the routing preferences.
Is it not working?
So the first thing you'll notice here is elbow at the very top. So an elbow at the top here is set to mitered standard, okay? Over here on the right is a little pull down when I click in this box. When I pull that box down, this is all the rectangular elbows that have been loaded into this project. So you see I have a 1 width radius all the way to a 2 width radius elbow and just your standard miter. But again, the reason I'm starting here, everyone, is because this is the number one question that I get is specifically when it comes to duct routing. So where's the mitered elbow with turning vanes? We need to have that. It's a standard for where we design, right? The inspectors are going to be looking for it. Anybody who's reviewing the documents is going to be looking for it. So we need to make sure we have that mitered elbow. Well, that's why this lovely load family button is right here. So if I click on that load family button, that should bring me out to my Imperial Library on my desktop. Now, if you have reset this up through the settings in Revit to have this point to a universal centrally located library, that's even better. But if you haven't set that up, all of this will be pulled from your local library that is installed on your C drive when you install Revit. But if I come into this library, open up the ducts folder, go into fittings, and then rectangular. Elbows. Right here, you'll see that you have a double thickness turning vanes elbow. So you guys can see that image there and kind of how it would report and print. Here is the single thickness turning vanes elbow. So you see, it shows a few more vanes, but they're just a single line there. My testing with both of these, I prefer the single thickness vanes. And the reason that I prefer those is because I think they print just a little bit more clearly than the double thickness vanes do. One thing I want to draw your attention to, everybody, is how the library for sheet metal fittings has changed over the years as Revit has evolved. I remember a time, as well as other people on the call may remember a time, Revit 2013, 2014, where this was a pretty limited library. And now at this point, you can start to see that you have lots of different options. Things like round throat, sharp radius heels. Okay, radius elbows, standard mitered elbows are here, but even eccentric adjustment Ls, right? Things with transitions built into them. These things were not commonly inside the Revit library years ago. So if you haven't come back to the fitting library and reviewed it with your new installations of Revit, I would definitely recommend you do that, because the library is getting better. So if I choose to load in single thickness veins here, if I just click on that right now and click open, that obviously loads it into my project. Puts it up here under duct fittings. Okay, this is where it would be. And so now if I came to elbow, rectangular, elbow, mitered standard, and I drop that down, you see that it shows up right here as an option. So I just go ahead and select that. Now it's in there. That's the elbow that will be used for all of my routing with this particular duct family type. Now, you notice I also have a little plus sign right here. I can put in another fitting here if I wanted to. So let's say in the example, if I don't want to use, for some reason, I can't think of a good one, but just back to the mitered standard elbow, I could have both these elbows inside of this list. However, no matter how many elbows I put in here, everyone, this is always going to be the primary elbow used, okay? Size delineation is the only thing that changes this. As you see that you don't have a size delineation option inside of this routing preference. So if you do want different routing preferences with different fittings, the best way to go about that is not to add a bunch of fittings to this routing preference. It's to duplicate this duct type and create different routing preferences, naming them accordingly as you move forward. So if I come down here to the preferred junction type, you see that that's a tap, okay? I can choose between a tap or a T. That's where the tap and T's come from out here, okay? Now that I've got that tap in there, I can choose which tap that is going to be. Here's the different takeoffs that are available loaded into the project. Again, I could load another one in if I wanted to. Ah, yes, I'm getting a question about, is there a way to turn off turning vanes? Yes, they're under the generic models category in visibility graphics. It's one of the more frustrating things. The generic model turns, checking that box on and off, turns off the turning vanes inside of the mitered elbows with turning vanes families. But if you turn off, say, duct fittings, for example, it turns everything off because it's a nested family that lives inside of the rectangular elbow mitered family. Oh, and I removed the wrong one. Good thing you asked that question, because now I'll put this back to the right one. Of course, different takeoffs can be loaded in everybody. Crosses are pretty much the same way. Transitions are pretty much the same way. I want to see what transitions are loaded in here. Rectangular transitions, all angles based. Another thing that I usually like to do is load in a different transition as well. The reality of most transitions is that they're not going to be angles based. They are going to be length based. So I will come in here and grab my length based one right here and load that in and set that up as well. Then of course, multi-shapes, how you want to go from rectangular to round, how you want to go from rectangular to oval. Those can be set here as well. Oval to round, if you wanted to put something inside of here, you could. It wouldn't provide you a whole lot of benefit though, right? Because you wouldn't be coming to this to run you wouldn't be coming to this to run oval or round ductwork. And then of course, union, which is nothing more than a connector. And then a cap. Which cap do we want to use? Pretty standard stuff, right? Once we've gone through and we've set up this routing preference and we're going to go ahead and use it inside of our project, I always like to test it. That's the first thing that I want to do is test, make sure all this is verified and working. And so the first thing I'm going to do then is I'll click OK to get out of here. And I'll come back and grab some duct. And I want to make sure that I'm drawing the right one, which is the mitered elbow with taps. Make sure my elevation is set well. Here's my width. I'm actually going to make this a little bit wider. And I'll come in here and start routing some duct work. Just going to draw a little piece here, maybe go up. I'm going to see how that mitered elbow turned out. It did put in the mitered elbow. See how it looks with thin lines versus thick lines. Things are looking okay. If I come back and look at this elbow, a lot of people forget about the plus signs and what they do and why they're there. This is the easy way to take a T or an elbow rather and turn it into a T in multiple ways. Of course, I can hit that minus sign, turn it back to an elbow, and it's good to go. Now, we want to show you exactly how we can deal with these turning vanes. So I'll go ahead and go into my view. Actually, there's no view template applied here. Should be. Since there's not a view template applied here, I'll just hop into view, go into visibility graphics, scroll down to generic model right here, uncheck that box, click OK, and you'll see those turning vanes go away. Now, of course, that's a categorical control, everyone. So keep that in mind. If you turn that off and there's other things underneath that category that you'd like to see, that makes it kind of difficult. Okay. Sometimes you can go in, and I've done this before too, it's a little bit of work, but you can go in and change the category of the nested family inside of the Turningvanes family, and that just gives you different control. So there we've tested out our first routing preference here. Let's make sure that we can do place some taps and some T's and make sure that works. So I'm going to right click on this ductwork. This is one of my favorite things to do. I'm going to select the ductwork, right click on it, go to create similar. And the reason I do that is because it pulls the elevation and the size properly. So I don't have to go back and reset stuff. Even if I wanted to change this size now, you'll notice that the elevation doesn't change. So I can just simply right click, create similar, change my duct size and keep routing my duct. So if I come here and I'm going to draw a little bit coming off here, I want to make sure that that tap works for me. Tap works good. Of course, I can do a tab selection. If I hover over and hit tab, everything that's connected will show me that it's connected as long as I keep hitting tab, like you see here. This is a good way of being able to test that my connections are working and that Revit will be able to transfer flow and do all the things that we needed to do from an analytics standpoint. So that is the duct routing preference stuff, if you will. It's basically, guys, from there, it's wash, rinse, repeat when it comes to setting up your routing preferences. We would set them up obviously a little bit different for round, then for oval, then for rectangular. So let's get into a round one here just really quick so we can see what the differences are. And the thing is, guys, is that with the short radius ones here, where I'll start, let's go to the type properties on that, and you'll notice that the settings are not different. The settings are basically the same. However, you're thinking of round now, so we're putting in round fittings, round transitions, right? Square to round, multi-shape transitions are going to be in here as well. And of course, we come down here and drop down, we see that the 1D elbow is loaded in here. Going a little off my script here, but I'm pretty sure that there is a 0.5 fitting in here. Maybe I was incorrect. You see there's a mitered round in here. There's a lot of different fittings that are in here now that didn't used to be in here, but I thought we had a 0.5 round. Looks like I was incorrect in that. So like I said, guys, it's wash, rinse, repeat. We're just paying attention to the different fittings we're picking here. Cancel out of that and cancel out of that. Got a question about changing lengths of a takeoff, like you see here. Here's the takeoff length option right here. See, that's 4.5 inches. What happens if I change that to 2 inches? You see that your takeoff length changes. If I come back and click on that and say I need to make it a 6-inch takeoff, it'll stretch to be a 6-inch takeoff. You also have a length multiplier right here of 0.25. This is going to be any overlap that goes into the ductwork, like you see right there. Okay, hopefully that was able to answer your question there, everyone. And if we got some time later on in the webinar here too, I might as well get into some tips and tricks for ducts and things like that. Got a question about the fittings in the ASHRAE database. The fittings coefficients are based upon the ASHRAE loss method. So you look right here, when I click on a fitting, loss method is right here. Here's loss method settings. And what this is doing, guys, this is going out and reading an ASHRAE table. This one's not finding it anymore. Let's see if this one finds it here. No, still not finding it. Here's my frustration there, since this is the good, the bad, and the ugly part about this. This ASHRAE coefficient table that you see right here for loss method. This is nothing more than a really big TXT file inside of Revit that Revit reads. And if you've ever looked at that TXT file, it is something that's very difficult to read if you're not a computer. And so making heads and tails over of what coefficient this particular fitting is using is sometimes not the easiest thing in the world to do. When the loss method settings show up here, you get a little table and you can do some work with that. I don't know exactly why all of this isn't popping up, probably because I don't have it on a specific system quite yet. But if you also come into here to loss method, you'll notice that if you hit this drop down that you can have it not defined, okay? Or you can have it defined as the coefficient table. When the editing is worked, you actually get to put in your own coefficients. So you get to be the arbiter of what coefficients are being used to play with your static pressure calcs. Of course, system inspector can be utilized once everything is connected so that you can look at piece by piece, part by part, run by run, what your static pressure is looking like and what Revit's seeing in terms of what's my worst case scenario run. So now that we've set up, gone over rather, setting up some routing preferences, guys, routing preferences are not difficult things to do. The first things that we just need to make sure that we have are the fittings that we want to use. Once the fittings that we want to use are installed inside the Revit environment, we just simply tell them where they're going to be utilized in terms of routing preferences. Literally is wash, rinse, repeat. But let's talk a little bit about duct sizing itself as it pertains to the fittings, because I mentioned earlier on here that, pipe fitting size based upon a lookup table. And if you don't know what a lookup table is, if you come into the family editor and you go into where your family type parameters are living, you'll notice that there is a manage lookup tables button right here. And if you click that with pipe fittings, all the lookup tables that make pipe fittings work would be listed here. Okay. Got a question again about the coefficient table. Guys, you don't get to set up the coefficient table. That's something that's hard coded into Revit. You just have to deal with what Revit has set up. It does come based upon ASHRAE stuff, but like I mentioned, going into that TXT file and you could change that information. But if you're not a computer, it's tough to make heads or tails of it. It's something that I have played with a couple times and haven't really cracked the code on it yet in terms of how it works. There's lots of blogs out there of everybody else who's been trying to get into that as well and kind of figure out the magic behind it. The way that I've always played with the coefficients, everyone, is to set my own, if that's something I'm looking at, running a static pressure calc in Revit, wanting it to be super accurate, I will go through the system and set my own coefficients per the fittings that I have in there. But we're getting out of managed lookup tables here because I want to show you how these things size. So here you have duct length, duct height, duct width. Okay, you'll see what the values are, but you'll see that all of this is being driven by equations. So this is how ducts understand what the lengths are, what the widths are, or what the depths are based upon what they're connected to. It's always coming back and reading these formulas. And so if we want to play with ducts and what sizes they are, if we need a deeper throat or things like that, this is usually where you have to come and play with this. Now, if I cancel out of here, and that was just to show you where those come in, and I'll go ahead and get out of that particular view for the family editor. Some of these fittings, especially ones that you can find online by some of the manufacturers. Here you have the duct width and height here, excuse me. But your shoulder length right here. What happens if we change this to a 3? Can we see what shoulder length means here? I would have called that a throat back in the day, but we can keep adjusting this information to make sure that we can minimize joints, minimize connection points, right? Especially if we're on the contracting side of the business, this is something that's really important to us. We're always looking at making joints less and not more. And so this is where you can come input some of that information so that you can get away with those situations, right? One of the things that I also loaded in here was a transitional fitting. So what I'm going to do here is I'm going to come up here and I'm going to do another tip and trick here and then draw some more ductwork. So what I'm going to do is I'm going to right click on the node. You'll notice that as I select the ductwork, that node is blue. If I hover over that node, it turns kind of a dark magenta, dark purple, some may even say maroon. If I hover over that, it turns that color and I right click, I get a draw duct option. When I use that draw duct option, it grabs the same width, the same height, and the same elevation. So then I can just simply come in here and say, okay, this is going to be 16 by 8. And then I'll draw some more ductwork, which should put in the transitional fitting. Now, this being a length-based transitional fitting, I'm able to come in here and type in different lengths, and that transitional fitting just adjusts based upon the lengths. And so this is what I can use again to start manufacturing joints out of my design, something that's more important for contractors, I understand. But it also gives you more control as an engineer when you're looking at trying to make some of this stuff fit in some of these scenarios that you're given in a lot of the buildings that we're working on today. Let's face it, a lot of the buildings that we work on today, they're guarding every square inch inside that building, making sure it's utilized for something. And so this is one of those tools that you can use to make your life a little bit easier. You'll notice that you also have a straight in and a straight out. I can come here and I'll set this at 2 inches and I'll set this one at 2 inches. And so you can see that it makes the adjustment for the connection there, whether that be a slip and drive connection, whether it be a TDC connection, duct mate connection, those connections, those throats, and everything can be adjusted for you. One of the other things you'll see here that a lot of people forget about is the width and the height offsets. So I'm going to stick with the width offset for now, just because you'll be able to see this. So we see that the width offset is 10 inches right now. What happens if I make it 12? You'll see it goes eccentric to one side. What happens if I make it 8? Goes eccentric to the other side. Willing to bet that if I made this an 8, then now I have a bottom flat or a top flat with a right side flat in terms of this. So let me go ahead and draw a section here and we'll verify what that setting is. Helps if I'm on a fine level of detail, and we can see right there, even though I'm in my floor above, that yep, that went with a top side flat and a right side flat. Another way that you can accomplish this, everyone, without having to come in here and mess with numbers every single time that you want to adjust this particular fitting, is if we have this duct in the right spot like we do here, you can draw the smaller duct first, then drag that smaller duct into the bigger duct, and it will pop in that eccentric for you, so that you don't have to come in and play with any of the numbers to make it look more realistic with what you're doing. That'll be a nice little tip and trick for you guys to be able to use. And of course, if I've done that, I can always come back in here and play with these numbers again to get more of a fitting that, or get a fitting rather, that is more reflective of what it is and what I do and how I deal with duct routing preferences. Another little tip and trick about duct routing, and this is one that I use all the time in training everyone, and this is one that I really took full advantage of when I was in the field. It has to do with something that isn't duct. I'll come to my systems tab, and it has to do with reference planes. Reference planes are something that is commonly used for hosting or guidelines and scenarios, right? Tracing out drawings, whatever we would typically use them for. But the way that I used them when I was using duct was a little different. And it was a very simple way to use routing preferences. In essence, everyone, all I really did was say, hey, since reference planes, no matter how infinitesimal I draw them, they exist infinitely across the project. Let's take and use advantage for that, or use it to our advantage rather, excuse me. So I'm going to grab my reference plane command, and you'll notice I have a chase here. One of the biggest things that we deal with in HVAC is understanding where our risers can go, right? Is this something that is going to work out on the floor above, at the roof? How do I know that? So if I come into an area like this where I know where one of my chases is, and then I go ahead and look at, maybe I see I'm on level 1, let's go up to level 2 and see what that looks like. And you'll see how I can guarantee just by that little X there, okay, that chase does exist on the second floor. It looks like maybe I got something that nudges into that, maybe that I might want to call the architect on, see if that's real or a mistake, but I can see that that works there. Then I can go up to the third floor. Does that chase still exist? Yes, it still does. Great, I got a straight shot. And then I can also go up to the roof and say, okay, if I'm coming down with ductwork from the roof, or I need to place a unit somewhere, whatever, this is where that hole exists on the roof. You can also go down into the basement, say if this has to go all the way down to the basement, this is where that would come out. And I can do that for lots of different things. There's huge advantages that you can use with reference plans. I really recommend that you use reference plans in any scenario like this. I can't tell you how many times I have caught mistakes in the model by the architect just simply by using reference planes. Anybody who has worked in Revit models of high rises, for example, there's usually a couple shafts, and sometimes those shafts are intended to shrink from the north side of the shaft or the south side of the shaft consistently as the building goes up. But sometimes when they're modeling, they forget about that, and you'll find this is an easy way to catch a shaft that shrank from the wrong size if they forgot, or wrong side, excuse me, or if they completely forgot to put a shaft on a floor. Just drawing a couple reference planes in there and reviewing those all the way up will show you your routing options, if you will, as you move forward. Same thing with stacked mechanical rooms, electrical rooms, whatever you can think of. Taking advantage of reference planes is a huge benefit there. So I also promised inside of the webinar that we were going to talk a little bit about the differences between systems, duct system types, and duct types inside of Revit. So we looked at duct types, okay? To make a new duct type, it's one thing I didn't show you exactly yet. We can simply right-click on an existing duct type. We can duplicate that. We right-click on it again. We rename it, and we may say, this is taps with turning vanes or something like that, right? Just so we understand what our routing preferences are. So we can rename those. And again, we can reorganize and restructure this to make it reflect more of what it is that we do as a firm. But when we talk about systems, it's important to understand that your systems are just what the ductwork carries. The routing preferences are the ductwork itself. So if I come in here to the supply air system, for example, I'm going to go to the type properties there, and I'm going to look at this particular system and how it's set up. So you'll notice here that you have your material, which may benefit you, may not benefit you, depending upon what you're doing. Materials are largely used for rendering inside of Revit. If you want to try to render air, be my guest. Your rise and drop symbols are going to be here under your systems as well. Your rise and drop symbols, unfortunately, are what are locked out of the box. This is what Revit gets you. And of course, these are only applied in the event that you penetrate the view range. So this is where you would make that selection here. But your graphic overrides are probably the most important part of your duct systems. So if I go into there, you'll be able to see this is where you can apply the line pattern, the line color, and the line weight that's going to be applied to the supply air duct system type. So if I want to change this, for example, to red, and I'll click OK here and OK. You see how that's updated to red automatically because this was all based upon that system type right there. And you can see I can put it on any system type that I want to right now because it's not connected to a piece of equipment that's defining what the system classification is. So I wouldn't be able to do system types, wouldn't be able to do my due diligence if I didn't talk about system classification along with system type. The system classifications inside of Revit for everyone for ductwork are going to be just like you see in the system types list right now. It's basically supply air, exhaust air, and return air. Now, it's important to understand that what system classifications do inside of Revit. System classifications drive the analytics and drive that calculation capability that Revit has. System types do not do that. System classifications do that. I cannot create or destroy system classifications. They are hard-coded into Revit. Can't do anything about them. However, I can make as many system types as I want. Those system types have to be based on at least one of those three system classifications that I just mentioned. You'll notice that here I am with the system type. I can change the system type. Go to return area. See how the system classification changes here, but I can't change the system classification. I can't click in there and change that. Even if I were to come back here to the return air duct system and go into its type properties, Here's its system classification. See, it's grayed out. I can't do anything about that. So it's important to remember that when you're going about making system types, that you want to duplicate the right one here, because these are in essence the system classifications right now out of the box. So if I want to make something that should fall under the supply air system classification, I want to duplicate supply air, then rename it. Okay. A common one is outdoor air. And a common one for outdoor air is to be in the supply air system classification and the return air. And the reason for this is simply because outdoor air can do a couple different things for us depending upon our application for that system. It can either be something that's getting pulled from the outdoor and getting dumped into the return, or it's getting pulled from the outdoor air and getting put someplace else, like say, for example, a direct fire makeup air unit or something like that. You may want to count that as typically supply air as far as Revit understanding the flow and the direction of the air. And so that's why this is something that's done in both the return air and the supply air areas. So if I just go ahead and rename this here, I'll call this one just O-A, just so we don't have something that's mixed up between outdoor air and air here. So I hope that makes sense to you guys. Got questions about connecting different systems to each other. As long as your system classification is similar between the two, Revit does cross-system connections very easily. However, if you're trying to take an outdoor air system, say for example, that is on exhaust air and connect that into return air, Revit's going to want to change that to either be all return air or all exhaust air, depending upon the direction of the flow and the size of the ductwork and where that system is connected into. Now, what is important to note is go through and understand system classifications, make your system types in accordance with what you would need from a connection standpoint. Another thing that you can do are, in essence, what we commonly refer to as hockey puck style connectors. Little connectors that are no bigger than a takeoff or something like that, that are in essence a duct fitting that has one system on one side and another system on the other. You run into this commonly in build types that have, say for example, a high-rise building that may have nothing but a row of louvers above the third floor, where those louvers could be anything from connection for outdoor air intake, for an exhaust, for a grease vent, for kitchen, right? Those need to be defined where those connection points are taking effect. And since they need to be defined there, that family really starts helping you define what those connections are. Another thing that you can do in those situations, especially as it pertains to louvers and mechanical equipment, diffusers is another big one for this. Go in and edit the connector inside the family to be a universal connector rather than a specific system classification or system type, because that will allow that piece to take on the system properties of any system that's connected to it. For example, there's lots of grills out there from every manufacturer, be it Price or Titus, whoever makes it, right? That grill is just a grill. It can be used for exhaust. It can be used for return. Heck, it can even be used for supply if we're being lazy, for example. But the point is that we want to be able to take that one family and use it across a lot of different systems. And if you guys would like to see a webinar on how you go ahead and do that, please put that into the chat right now. And I'll make sure that we plan one around that and how we do those settings and how we overcome some of that, so that your grills at least can become much more universal for you in your use cases than they currently are, especially as we download them from manufacturers. Well, everyone, went over duct routing preferences with you guys. As you can see, it's not very complicated. It's just a matter of sitting down, getting your things straight as that you want to do, keep moving forward, and doing your basic setup, guys. There's nothing extremely complicated about doing routing preferences in Revit. A lot of the times we just have to sit down and do it. Showed you how we could adjust some elbows and adjust some fittings, changing a concentric transitional fitting into an eccentric transitional fitting, how we can adjust throats on and connection points on elbows, how we put the mitered elbow in there and control that graphically, how we can adjust the lengths and everything on takeoffs, of course, how we can change fittings from elbows to T's, all sorts of different control we have in here. But as long as I've got you, and I got a couple more minutes here, I'm going to switch over to a different version of Revit and kind of that has a data set in it already, where I could show you some other things that you can do with ductwork that you may want to take advantage of. So here what I'm showing you is nothing more than a color legend. If you go to your Analyze tab, you can put color legends together for ductwork. What I've done here is I have set up a color legend to basically take that ductilator out of my hand and put it here inside of Revit. I can't stress enough, everyone, that the ROI on Revit, where most of us are trying to go to get our money back for all the work and all the time we've had to put in Revit, is with the analytics. And when I have everything connected, modeled properly, I am propagating flow, and I have a basis for design in here in terms of a GBXML workflow with heat loss, heat gain calcs, or I have Revit tuned where I can use that. When all that data is in here, Revit becomes a hugely powerful tool. And what I'm about to show you right here as an example. And so I'm just going to click OK here, and I'm going to go to this really simple scenario. As you see, this scenario is all green. If I come here to my legend, I'll see that that indicates that it's lower than 0.08 inches of water column for this portion from this VAV to this very simple diffuser. If I come in and I select this piece of ductwork, you'll notice that that is 8 inches. Well, what happens if I change it to 6? You'll notice the color changes. It goes red. That means I'm over 0.16 inches of water column. Probably a little too loud, a little too much pressure than I want, a little more pressure than I want in this design. So I'll simply come in and say, hey, let's change the duct size, right? An 8 was working, a 6 is too small. What happens if I want to be that guy and say, well, hey, let's use an odd number. Let's be that guy and see if that works. Well, it turns blue. Kind of in my range, kind of not in my range. But again, not going to be that guy. Let's go ahead and put that back to an 8 where it was. It's inside my range. Little things like this, everyone, these can help you not necessarily automatically size ductwork, but be able to come in here and review your design very quickly. Make sure your duct sizing is working, right? Coming in and looking at areas like, okay, wow, this is all red here. Is that okay? Why is it all red? Maybe I do need to review my duct sizing. Of course, friction is not the only thing we do. As you see, I have this set up for friction in this particular view and all the levels. We also do it by velocity. So guys, this is just another color legend, same concept, same everything, just simply measuring feet per minute rather than static pressure. Works the same way. Just start changing some sizes. So everyone, I hope that you were able to get some stuff out of this webinar. I'm going to go through the questions here and hopefully be able to get all your questions answered. All right, I have some people requesting the Universal Connections webinar. Great, awesome. I will make sure that that gets added to the list of webinars coming up. I'm writing it down right now. Connection webinar. And the recording of this will be made available to you guys. Of course, it's going to, all of you will be notified when the recording is ready to go and is placed up for us to view. So that will happen. Do the turning vanes show in a 45-degree elbow? Great question. I'm going to come here and put one in to show you here. So since this is just a generic model that's embedded inside of the ductwork, this will always show unless we turn it off, okay? Some people who've made their own turning vane elbows, so if they click on this elbow, for example, they'll have controls here to turn things on and off in terms of the turning vanes. Here you have this using annotation scale for graphics. If you uncheck that box, that does change the scale of this generic model when it's in there, but that has to do again with the annotation scale and printing and everything else. So you usually want to have that turned on anyways. Yep. All right. Got a question about using Revit for analytics and getting that set up. That could definitely be another webinar topic, guys. The nice thing about Revit and analytics is there isn't a ton of setup that has to happen as much as we change our workflows a little bit. And we have some faith in doing some things inside of Revit, because Revit is always trying to analyze information for you. Just as we look at this now, as I click on these pieces of ductwork, you know, they're not propagating any flow right here, but I have the ability to put an additional flow right here. So I can start manipulating these numbers and making things more in tune with what it is that I'm trying to do. But I will definitely add that to the webinar list as well. Something that we can do in the past, using in the future, excuse me, using Revit for analytics. Yeah, I'll be all over that for you guys. Yep. So it looks like we got a lot of questions about analytics in Revit. No problem. One of the things that you may want to look into, guys, if you haven't looked into it yet, CTC does make a product called the Mechanical Electrical Plumbing Productivity Pack, where we have set up all that analytics stuff for you, so it just works inside of Revit. Set up families and everything else to make sure that it stays intact as you move forward. So that's something that you could look into just simply by going to CTC's website and putting in some information. They have a little treasure chest that you can download there, which is the shared parameters file inside of that, the user's manual, so you can take a deeper look at that without having to be, beat up about a demo or anything like that. So you can just look at it at your leisure. We got a question about how we get our device airflow to add to the ductwork. Well, in order to first understand that, guys, we have to understand how Revit calculates flow. And this will be, unfortunately, guys, the last question that I'm able to answer here before I have to get off. When ductwork is connected to devices, we have to understand that what this device is reading. So you see the minimum supply here on this VAV system, for example, is 60 CFM. The supply airflow is 200 CFM. But that airflow is not being driven by this VAV box. Revit sees things backwards. So Revit's looking here for that 200. That's where that's coming from. It then flows everything backwards down to your pieces of equipment. And I know that is 180 degrees out of phase of how we have all thought about flow in ductwork throughout our entire careers, right? This is not how you're taught to size ductwork in school. This is not how we think about flow. We always think about it coming from the piece of equipment. That being said, this is how Revit works. And one of the hardest things that I've had to do in my career, guys, is make my adjustments from how I know things should work to, okay, this software looks at it this way. There's nothing I can do about that. So let's learn how the software looks at it and then learn how I can manipulate that based upon how the software sees it. So if I look at this particular piece of ductwork here, you'll see right now that is registering at 200 CFM right now. If I come back to this diffuser and I change that to 300 CFM, you'll notice that that will change. But if I come back to the VAV, if I come back to the ductwork, now that'll be up to 300 CFM. And what you see here is this is taking a little while because it's going through some selections here. So if I come back to this piece of ductwork, you see how this is now reading 300 CFM. Come back to this piece of equipment, you see this is now reading 300 CFM, but because of what we've done with this particular family, it's auto-calculating my min for me here at 90. Outside of understanding how Revit flow actually works, that it flows backwards like I just explained, the other ways of making sure that your device error is being calculated and things are working, guys, is just simply making connections and making the good connections where Revit knows what to do. If Revit doesn't have a connection, or if we're faking something to make it look good on a plan sheet or something like that, we're throwing all the ROI capabilities that we have with Revit out the window. And I say that, guys, fully understanding the situations we find ourselves in, especially from an engineering perspective, in terms of investment in time and modeling, what we're actually getting paid to produce at the end of the day, what we want to be responsible for, juggling and balancing what the LODs are, what's our role in this specific project, are we on design assist, are we helping with design build, are we just doing regular plan spec, straight design. So all those things play into how we're going to utilize Revit. And you need to have a plan for maximizing your efficiency and gaining your ROI for each one of those different project types, because each one of those is going to require you to really do some things differently with Revit, especially if you're the expectation of that particular project would be to pass this model on to the next level, be it, say, for example, a standard plan spec workflow. This model being passed on to the contractor and setting that model up for them to be able to be the most efficient user of that model as it grows and moves into an installation model. But lots of other things we could discuss here, guys. Unfortunately, I'm out of time. I do really hope that you definitely enjoyed this webinar today. If you didn't enjoy the webinar today and you think I could get better, by all means, tell me. I want to know if I did a good job or a bad job. It's the only way I know how to get better, everyone. And again, thank you so much for the suggestions for topics moving forward in webinars. We'll definitely cover all those for you. And if you got anything else that you need questions or have questions on or need help with, obviously don't be afraid to reach out to us here at ATG. We're always here to help. Big believers in the partnership model, everyone. Your success is our success. Once again, guys, my name is Don Rasmusson. A lot of people in the office call me Raz. That's where that comes from. So if you've got any questions or anything, don't be afraid to reach out. You can call our support line. You can email me directly at drasmusson@atgusa.com. Hope to hear from you soon, guys. See you a little bit later down the trail in terms of the webinar stuff goes. So thanks again so much for attending, everyone, and we'll be talking to you soon.